Dear students, welcome to all of you. Today we discuss MCQ of 2023 Biomathematics paper, semester 5, CBCS Mathematics Honors, University of Calcutta. The question paper DSE A 1.2 2023 Biomathematics, question 1A. In the following model, 1 by n ddt n equal to r bracket 1 minus n by k whole to the power theta, r, k, theta being positive parameters, the steady state n star equal to 0 is what? Correct option is 1, unstable. Let ddt of n equal to fn, where fn is this r into n bracket 1 minus n by k whole to the power theta. Then f dash n with respect to n, derivative with respect to n equal to r bracket 1 minus n by k whole to the power theta bracket close plus r n bracket minus theta n by k whole to the power theta minus 1, derivative of this with respect to n into 1 by k. Now, here it is given that n star equal to 0 is steady state, and then value of f dash n at this trivial steady state n star equal to 0. Obviously, put n equal to 0 here. So this equal to r, and this n equal to 0. So this equal to 0. So f dash 0 equal to r. And since it is given that r is a positive parameter, so this greater than 0, f dash 0 greater than 0. Hence, n star equal to 0 is an unstable steady state. So the option 1 is the correct answer. Next question, question B. In Gompertz goat model, ddt of p equal to Cp ln k by p. The population p grows fastest when p is equal to what? Actually, this question, C, details answer to C in the question for 2021, question 1C, MCQ 1C. Here, let ft equal to Cp ln k by p. Then f dash t equal to this ddt of p, again ddt of ddp of this into ddt of p. So after simplification, f dash t equal to equation 2, c bracket ln k by p minus 1 cp ln k by p. Now f dash t equal to 0 implies either this factor ln k by p minus 1 equal to 0 or this ln k by p equal to 0. And from this p equal to 0, but here p is not equal to 0, is positive parameter, because this if b equal to 0, this is undefined. So either p equal to k by e or p equal to k. Then f double dash t, this derivative against with respect to again 2. we get this c square into this plus c square into this plus c square into this. After simplification, using this dvdp of ddt p equal to cp ln k by p, using this we get c cube p into this ln k by p whole square minus c cube p ln k by p whole square minus c cube p bracket ln k by p minus 1 into ln k by p. And then if double dash uh, p equal to k by e, put here p equal to k by e, we get minus c cube k by e. Obviously, c, k, e are all positives, so this is negative, less than 0. Thus, p grows fastest when p equal to k by e. So the option 4 is the correct answer. Option 4 is the correct answer. Actually, note that this f dash t is positive. F dash t is positive when from this equation 2, when ln k by p minus 1 is greater than 0. So ln k by p minus 1 greater than 0. So ln k by p is greater than 1. That is this 1 equal to ln e. So k by p greater than e. And then k by e greater than p. That is p is less than k by e. And f dash t is less than 0 when k by e less than p less than q. So if we draw this axis p axis, this dpdt equal to f function f. So actually this interval, within this interval 0 to k by e, this f dash is positive, and when k by e to k, f dash is negative. So this that is ft, that is equal to dpdt, has a maximum, and p grows fastest when p equal to k by e. If we draw this graph, time axis t, and this is the along this y-axis is p, we get this sigmoid curve. This point is k by e, and this point is k. And so from this to this range, p double dash is negative, that is f dash is less than 0. And this point, p double dash equal to 0, that is f dash equal to 0. And within this range, k by e and k, this f dash is greater than 0. And this is this. So p grows fastest when p equal to k by e grows fastest. P grows fastest when p equal to k by e. So correct option is here 4. Next question, C. In the following harvesting model, utility of n equal to Rn bracket 1 minus n by k bracket close minus q e n, where the symbols have their usual meanings. The non-trivial steady state exists if correct option is 3, q e by r is less than 1. Now it is given that the ddt n equal to Rn bracket 1 minus n by k bracket close minus q e n. And this right hand side equal to f and say for steady states instead, and ddt n equal to 0 gives this n star r bracket 1 minus n star by r, okay, sorry, k bracket close minus q e n star equal to 0. So taking common n star, we get this n star common, and this r into bracket 1 minus n star by k minus q e. So n star equal to 0, either n star equal to 0 or r bracket 1 minus n star by k bracket close minus q e equal to 0. So we have two steady states, in one star equal to 0 and other steady states n2 star. Non-trivial steady state, this equals to from this equation k into bracket 1 minus q e by r. Clearly this non-trivial steady states, this n2 star exist if This 1 minus QE by R greater than 0. That is if QE by R less than 1. So the correct option is 3. Next question, D. The system dd of x equal to mu x plus x square, where mu belongs to a real number, which is a parameter, has this. What is this bifurcation? What is this type of bifurcation? Correct option is 3. Transcritical bifurcation expression. Now dd ex equal to mu x plus x square equal to fx, where fx equal to mu x plus x square. Then f dash x equal to mu plus 2x for steady state x star, and dt of x equal to 0 at x star. So f x star equal to 0. So mu x star plus x star square equal to 0. So we get x1 star equal to 0, x2 star equal to minus mu. Then f dash 0 equal to mu, f dash 0 is this, so mu plus 2x, and f dash minus mu equal to minus mu. I put here mu minus 2 mu. This one, when mu is less than 0, so this mu less than 0, so f dash 0 equal to mu less than 0, here is stable, trivial steady state stable, and mu dash minus mu equal to minus mu greater than 0, unstable. So x1 star is a stable steady state, and x2 star equal to minus mu is an unstable steady state. S2, when mu greater than 0, f dash 0 equal to mu greater than 0, f dash minus mu equal to minus mu less than 0. Therefore, x1 star is an unstable steady state, and x2 star equal to minus mu is a stable steady state. The steady state x1 star interchanges its stability with another steady state x2 star equal to minus mu, as the parameter mu, this mu axis, is varied. So when mu is negative, this trivial steady state is stable, and this non-trivial steady state is unstable. X star equal to mu, we draw this dotted line, and at this origin interchanges their stability. So this after this, so when mu is positive, so this x star equal to 0, unstable, so dotted line, and this is the stable, x star equal to mu is stable. So for stability, due to stability, arrow towards this line, and so this stability, the arrow towards this line, this stability, and hence the system has a transcritical bifurcation at this point, mu equal to 0. So correct option is 3. Question E, if alpha, beta, gamma, delta are positive parameters, the nullclines of the two-dimensional system dx equal to x bracket alpha minus beta y, dy dt equal to y bracket minus gamma plus delta x intersect at what? Award 2 marks for attempting this question, because all our options here are incorrect. Option. Explanation: if the nullclines intersect at x star y star, then from this x star bracket alpha minus beta y star equal to 0, and y star bracket minus gamma plus delta x star equal to 0. So from this first equation, we get either x star equal to 0 or y star equal to alpha by beta. From the second equation, we get either y star equal to 0 or x star equal to gamma y delta. And hence the intersecting points of these nullclines, this x star y star is 0, 0, or x star y star is gamma y delta, alpha by beta. Gamma by delta, so no option here. Gamma by delta, alpha by beta. So all options are incorrect here. Actually, this is the wrong answers. Question: if the steady state 0, 0 of the following system, ddt of x equal to 3x plus 2y, ddt of y equal to 4x plus y is what? This correct option is 2, a saddle point. Explanation: let ddt of x equal to fxy and ddt of y equal to gxy. So fxy equal to 3x plus 2y, gxy equal to 4x plus y. Then find the partial derivatives with respect to x and y. Del f del x is equal to 3, del f del y equal to 2, del g del x equal to 4, del g del y equal to 1. The Jacobian or irrational matrix J for this given system, this equal to fx, fy, gx, gy is 2 by 2 matrix. This 3, 2, 4, 1, this constant matrix. So here, given that steady state, this 0, 0, a trivial steady state for this, so it's the same 3, 2, 4, 1. The characteristic equation of J 0, 0, 3 minus lambda, 2, 4, 1 minus lambda, determinant of this equal to 0. After simplification, we get lambda equal to 5 and minus 1. Eigenvalues are 5 positive and minus 1 is negative. Hence, for this negative eigenvalue, stable, and for positive eigenvalue, this unstable. So steady state is a saddle point variable. Correct option is 2, saddle point. Correct option is 2, saddle point. Next question G. The steady state 0, 0 of the system ddt of x equal to y and ddt y equal to bracket alpha minus 1 into x minus alpha into y, where alpha is a positive parameter and alpha not equal to 1, is asymptotically stable. If this condition, what is this condition? Let ddt of x equal to y equal to fxy and ddt of y equal to alpha minus 1x minus alpha y equal to gxy. And then if equal to y and g equal to this alpha minus 1 equate minus alpha y. Now we find partial derivatives fx, fy, gx, gy. The Jacobian of this system J, fx, fy, gx, gy, 2 by 2 matrix, this 0, 1, alpha minus 1 minus alpha. This is a constant matrix. So at the steady state 0, 0, previous steady state 0, 0, j 0, 0 equal to 0, 1, alpha minus 1 minus alpha. Now the trace of this Jacobian, and that is trace j, that is equal to the addition of these principal diagonal elements, this 0 plus minus alpha, this is equal to minus alpha, and determinant of this j 0, 0, this is equal to determinant 0, 1, alpha minus 1 minus alpha, this is equal to 1 minus alpha. By Routh-Hurwitz criteria, 0, 0 is asymptotically stable if trace j is less than 0 and determinant j is greater than 0. So minus alpha less than 0 and 1 minus alpha greater than 0. So alpha is greater than 0 and alpha is less than 1. And that is 0 less than alpha less than 1. Hence the correct option is 1. Next question, age. For the Carmack McHenry SIR model, S plus I plus R is equal to, the correct option is 5, 4 is constant. The KM SIR epidemic model describes by this density of S equal to Bk minus beta Si minus mu S, density of Y equal to beta Si minus gamma I minus mu Y, and density of R equal to gamma I minus mu R, where beta, the disease transmission coefficient, gamma, recovery rate, and B, birth rate, mu, death rate, and these parameters, beta, B, gamma, mu, are all positive parameters. And S is a function of T, they are susceptible, and IT is infected, and RT is recovered individuals at any time T. And total population, this KT equal to S plus I plus R at any time T. Also, we assume birth rate equal to the death rate, that is B equal to mu. Now, this model can be described by this flowchart. This S, this I, this R, this BK, and this out here mu S. So ddt of S equal to BK plus minus beta Si minus mu S. So this input here BK plus, and this output is mu S, and this outflow is beta Si, so minus. So dt of S equal to BK minus beta Si minus mu Si. So dt of I equal to this input here beta Si. So beta Si, the output is this mu Y, and this output is gamma I. So minus gamma I for ddt of I. And for ddt of R equal to gamma I minus mu R. Then adding all these, we get this bk minus mu bracket S plus I plus R. By this system 1, we adding this, we get this result. Now S plus I plus R equal to K. So this equal to bracket B minus mu into K. Assume here B equal to mu, so this equal to 0. So dt of S plus I plus R equal to 0. So S plus I plus R is constant. Hence the correct option is 4. Next question, I. The non-zero steady state of the logistic difference equation xn plus 1 equal to r xn bracket 1 minus xn bracket close 0 less than equal to r less than equal to 4 is asymptotically stable if what? Let xn plus 1 is equal to if xn, where fx is this rx bracket 1 minus x. For steady state x star is fx star equal to x star. So fx star is rx star bracket 1 minus x star equal to x star. So we get this. So either x star equal to 0 or x star equal to, from this factor, 1 minus 1 by r is equal to r minus 1 by r. Clearly, this non-zero steady state, this x star equal to r minus 1 by r exists if r minus 1 greater than 0, that is r is greater than 1. Now, x star is asymptotically stable if modulus of f dash x star is less than 1, and unstable if modulus of f dash x star is greater than 1. Now, f dash x, fx is this, so f dash x equals to r bracket 1 minus x plus r x into minus 1, so we get equal to r into bracket 1 minus 2x. So f dash r minus 1 by r, put here x equal to r minus 1 by r, non-zero steady state. So you get mod of 2 minus r. And this less than 1, if mod of 2 minus r is less than 1, that is this equal to this implies minus 1 less than 2 minus r less than 1. So this implies 1 less than r less than 3. Hence, the non-zero steady state is asymptotically stable if 1 less than r less than 3. So the correct option is 2. Last question MCQ. The difference equation xn plus 1 equal to alpha xn by 1 plus xn, alpha real parameter, has two distinct non-negative steady states if what? Correct option is 4, alpha is greater than 1. Explanation. For a steady state x star, we know xn plus 1 equal to xn equal to x star. From the given equation, I put this x star equal to alpha x star by 1 plus x star. Because for the steady state, we know xn plus 1 equal to xn equal to x star. So taking common x star, we get bracket 1 minus alpha by 1 plus x star, bracket 2 is equal to 0. So either x star equal to 0 or x star equal to alpha minus 1. If this positive, so alpha minus 1 greater than 0, that is, if alpha is greater than 1, the given difference equation has two non-negative steady states. This positive and this 0, so non-negative. Hence, the correct option is 4. Correct option is 4. This completes this MCQ 2023. Thank you for watching this video.